Welcome back to day 3 of our radicals unit. Today, our goal, given an expression with radicals, you will be able to correctly add and subtract the radicals. Okay, for today's lesson, you're going to need your list of your perfect squares and your calculator. So let's have both of those handy and let's get started. Okay, so when we add and subtract our radicals, we're always going to follow these steps. Step number 1, simplify all your radicals first. Start with the smallest ones first because that will sometimes help you along. Then number 2, you're going to add and subtract coefficients of radicals that have the same radicand. So we call those like terms. So they have to be like terms. So in order to combine radicals, you have to have a radical 2 and a radical 2, or a radical 5 and a radical 5. That's the only way you can then combine them with addition and subtraction. So let's go ahead and let's try this out. So number 1, if we look, we are adding. So 5 radical 3 plus 2 radical 3. Okay, so let's take a look here. So radical 3, can we simplify those with a perfect square, or is that as small as it goes? Well, that's as small as it goes, so we cannot add or subtract. Okay, or we cannot simplify. So now what we're going to do is we're going to add these together. So when we add, you're going to add the coefficients, and you're going to keep the radical the same. So this is going to be equal to, so you have 5 and 2, so 5 plus 2 is 7. And then the radical 3 is going to stay the same. Okay, because you have 5 radical 3s and then you have 2 radical 3s, so now we have 7 radical 3s. And with that, you are done. Okay, now let's take a look at number 2. So if we take a look here, I have a radical 5, a radical 20, and a radical 3. So right now, none of these are like terms, so we cannot combine any of them. But let's see, what if we were to try to simplify these? Well, let's see what happens. 3 radical 5, well, that one can't be simplified. 5 is as small as it goes. But how about radical 20? Can we simplify radical 20? Well, is there a perfect square in this list that goes into 20? That's right, it would be 4. So we can actually break this one down. So we're going to take this one and we're going to break it down. So 4 stays 4. And then times, and what do we have? We have radical 4 times radical 5. Now the square root of 4 is 2. So if I were to do that in my calculator, the square root of 4 is 2, so the radical goes away. So now we have 4 times 2 times radical 5. So really this is going to become 8 radical 5. Now can I simplify radical 3? No, so we can't simplify that. So now I'm going to bring these two down and keep everything the same. So 3 radical 5 minus 8 radical 5 plus 9 radical 3. So now, can we combine any of these? Do any of them have like terms? Well, here we have a radical 5, here we have a radical 5, so we can subtract these. 3 minus 8, well, that's going to give me a 5. Radical 5 stays the same. Now 9 radical 3 is not the same as radical 5, so it stays the same. And with that, we are complete. Now, let's say you weren't sure if this really worked. Well, we can always check it in the calculator. So 3 radical 5, oops, let's see if I can get that better. There we go. Minus 4 radical 20. Oops, see, I made a goof because that first radical sign is still going over, so I have to start this over. So let's try 3 radical 5. I have to use my over arrow, so I go to the outside of the radical symbol. Minus 4 radical 20. Use my over arrow, and then plus 9 radical 3, and then we hit enter. So this is the irrational number that this expression is equivalent to. So now let's try our solution. 5 radical 5 over plus 9 radical 3, and then we hit enter. Oops, so if I take a look here, I did something wrong. Okay, so I can see that these should be the same if I did it correctly. So I'm going to go back and take a look. 3 minus 8, well, that's not positive 5. That should be negative 5. Okay, so let's try this again. So negative 5 radical 5 over plus 9 radical 3. enter. Now, did I get the same answer as I did from up above? Yes. So now this is my correct answer, -5 radical 5 plus 9 radical 3. So the calculator is very handy because it can check your work for you. All right, so let's go down now and let's try number 3. So if I take a look at number 3, the way that it's written, nothing can be combined because all my radicals are different. So we have to simplify each of these radicals. So let's start with the first one, radical 48. Well, first off, is radical 48 a perfect square? Nope. So now what we have to do is we have to find a number from this list that goes into radical 48. And we want to make sure that we find the biggest one. So let's take a look. 48 divided by, and let's see, I know 36 doesn't work. 25 is not going to work. Let's try 16 divided by 16. Oop, and that works. It's 3. So I can take radical 48 and break it down into radical 16 times radical 3. Now the square root of 16 gives me a perfect 4, so this is going to cancel. We're going to get a 4. Now radical 3, it's not a perfect square, so it stays radical 3. Okay, now let's take a look at 2 radical 12. So is there a number in this list that goes into 12? Yep, that's going to be 4. So this is going to be 2 times radical 4 times radical 3. But then I know the square root of 4 is 2. So I can cross out the 4 and make that a 2. So now I have 2 times 2 times radical 3. So this is going to become 4 radical 3. Then if I take a look at 16, well, radical 16 is on my list, so let's double check it in the calculator. The square root of 16 is just 4. So this whole thing crosses out and we get 4. Now I'm going to bring down my operation. So there's a plus here and there's a minus here. Now, can we combine these? Do they have the same radicand? Yes, they have. So radical 3, radical 3. So 4 plus 4 is 8 radical 3. Now this 4 over here has no radical with it, which means it's unlike, so it just stays at the end. And that is our final solution. Now if we wanted to check that very quickly in the calculator, radical 48 plus 2 radical 12 minus the square root of 16, we hit enter. So we get that number there. So let's take a look. Now 8 radical 3 minus 4, we hit enter, and we see we have the same number. So we did this correctly. All right, let's go ahead now and take a look at number 4. Okay, so we're going to have to do a lot of simplifying here. So let's see what happens. So here we have radical 15 squared. So remember, when you square parentheses, you have to write them out twice. Okay, so radical 15 times radical 15. So remember, multiplying was yesterday. So 15 times 15 gives you radical 225. But now look what happens. The square root of 225 is just a perfect whole number 15. So that whole thing crosses out and we get 15. And I'm going to move that all the way down to the bottom. Now we have a plus sign. So let's see now, can we simplify this? Well, 25, wait a second, that's on my list over here. 25, that's a perfect square. If I take the square root of 25, we get 5. So this crosses off and we get a 5. So really, this is just 2 times 5, which is 10. So I'm going to move that down. Now we're going to come over here. Now radical 18, that one's not so perfect. Okay, that gives us that irrational answer. So I need to find a perfect square that goes into 18, and that's going to be 9. So this becomes 5 radical 9 times radical 2. But I know the square root of 9, the square root of 9 is a whole number 3. So I can change that to the whole number 3. 5 times 3 times radical 2. So this is going to give us a 15 radical 2. Now we're going to go to the last one, so radical 12. So I can break this down into radical 4 times radical 3. There's a 6 on the outside. Now the square root of 4 is 2, so this is really just 6 times 2 times radical 3, which is going to give us a 12 radical 3. And it's adding. So let's take a look then. So let's combine our like terms. I have a whole number 15, a whole number 10, so we can combine those. and that gives us a 25. Now if I look over here, I have a radical 2 and a radical 3. Those are not like terms. They cannot be combined. So my solution is actually a trinomial. And that is our final answer. All right, let's go ahead now and let's take a look at number 4. What I'd like you to do right now is go ahead, pause the video, and I'd like you to try this one on your own. When you plug it into the calculator, type in the number, write the word radical where there's a radical symbol, and then write the radicand after that. All right, let's see if you were able to simplify correctly. And then we get 20 radical 3 minus 1 radical 5. All right, last question for today. I'm going to put a little star there. So this one is definitely, this is what we're working towards. This is as complex as it's going to get. So go ahead and try number 6. All right, let's see how it went. So did you end up with 9 radical 2 plus 22? As a reminder, you can always double check in the calculator by plugging in your solution and the original expression. All right, folks, have a great night.